Okay, welcome to seventh video of analog electronics lab. So in this, we are asked to write an Arduino script to sense the signal from a temperature sensor and turn on the AC motor if the temperature exceeds 35 degrees centigrade. If the temperature exceeds 35 degrees centigrade, now we are asked to turn off the AC motor. So as we know that in the specification, the sensor is a temperature sensor which is LM35. The actuator is an AC motor which runs with 230-volt AC signal. The task is to turn off the AC motor if the temperature is greater than 35 degrees centigrade. The implementation is done using the Arduino board. So we know that the specification of the temperature sensor is 10 millivolt per degree centigrade is the sensitivity, and AC motor runs with a 230-volt AC signal. Now, since we are looking for 35 degrees centigrade, the output voltage of LM35 for 35 degrees centigrade happens to be 350 millivolts. These are some of the points to be noted. So Arduino should read the analog voltage, and Arduino must give a digital value to turn on the motor. The Arduino must give a digital value to either turn on or turn off the AC motor. Now we know that in a digital in Arduino, so if 0 volt is the input voltage, we'll get a 0 value, and if 5 volt is the input voltage for the analog input of an Arduino, so the value that is read is 1023. So naturally for 350 millivolt, the value that is read from the Arduino will be 71.61, which is approximately 72. That is, in the Arduino script, the analog voltage that is read has to be compared with 72, and we have to send a signal of 0 or 1 so that we can send a signal 1 if the analog value goes below 72 to turn off the AC motor. So this is what is the thing what we are supposed to do here. Now we know this is the Arduino board. So we know that we have A0 to A5 as the analog in, and we have the digital IOs, and this is a driver IC which is used to drive the relay, which will going to turn on or turn off the motor now. So as we discussed in the previous case, so this L293D has got 4 non-inverting buffers. So this one A1 Y corresponds to input and output. This is again the input and output of second buffer. This is for the third, this is for the fourth, and we have 2 enables for a pair of channels, and we have 4 heat sinks, and correspondingly we have 2 voltage sources VCC1, VCC2. So that's what is listed here. So VCC1 is for the internal logic operation, which is just 5 volts required, whereas VCC2 purely depends on what the driver that you're driving. Now this is one of the possible choice to implement this particular task. Now here we are asked to switch off the AC motor if the temperature goes above. If the temperature goes above 35 degrees, we are asked to switch off the AC motor. Now you can see LM35. So please identify the terminals properly as per the data sheet of LM35. You have to connect one terminal to in DC voltage, that is 5 volt, the other one to ground. One more pin is connected to the Arduino input. Either you can connect A0 to A5, any one of the 6 pins, and output, a digital output from the Arduino is connected to 293D. This is your first channel. This is the input. You can see it is enabled by applying 5 volt. Now this is VCC1, which is applied with 5 volts from the Arduino board, and we are using a relay of 12 volt, so that's why we are connecting this pin number 8 to plus 12. So this is connected to an external power supply. The ground of the external power supply is connected to the coil, and it's connected to the common ground of your Arduino also. So these 4, 5, 12 and 13 are grounded so that L293D operates properly. Carefully observe here. So this is for AC motor, so it can be a fan. So now it is connected, just a minute. So it is connected between, so you can see, so one end of the motor is connected to line, the other end is connected to common, and there is NC, so it is connected to NC. So normally when the current is not flowing, so assume that the temperature is So now when the coil is not energized, so this will be connected, so motor will be keep running. So when the energy when the coil gets the voltage, so that whenever it is get energized, so this NC will become open circuit, so the motor is going to turn off. The motor turns off when the current flows through this. When the current is not flowing through this, the motor will be on. So that's why it is connected from NC and the common. The other possible connection is this way, because we are using a transistor instead of a driver IC. This is now used to drive the relay now. So it's again, now you can see one end of the relay coil is connected to 12 volts, the other end is connected to collector. Suppose if you have the base drive, it turns on, so the current flows through this and it energizes. This NC will become open circuited, this will be get connected. So motor will actually turn off when current flows through this. When current is not flowing through this will be on. So this is how usually the connection is made. So it can be a bulb or a fan. Now we know that if it is connected to a 230 volt, we need to have two lines. The one line is directly connected to this. Now this is your pin, and in the other one, so there is a cut made, so there is a break in that line. So one of the line is connected to NC, the other line is connected to common. So it is connected between NC and common. So this is with the way how you can do the connection for this particular setup here. Now here this is the motor or the fan. One end of that broken wire is connected to normally connected, and the other end of that broken wire is connected to the common terminal. So this will ensure that when coil is not energized, the bulb or the fan will be running. When the coil is get energized, so this will become open, the fan will going to turn off. Let us have a look at the code what we have written for one of the possible code. So we have initialized the val to 0, and we are using the digital IO pin 10 to operate the fan. Now we are having a definition for, okay, we are describing pin number 10, which is set as fan as an output pin. So we are initializing digital pin 10 as the output, that is pin mode fan comma output. And if you want to see what is the voltage that is being uh, read, so that you can put it on the serial port. Now you can see now, so we are putting an infinite loop here. So the value that is read from, now you can see we are actually reading the value from pin number that is A1. So that's why it is analog read 1 will be assigned to var. The analog voltage will be read from LM35. The same value will be displayed on the serial port also. And you can see if the value is less than 70, because it can be 72 or 74, so this can be 72. If it is less than or equal to 72, if this statement is true, you are putting a low here. So you are writing on pin number 10, which is fan here, is low. Whenever this condition is true, when the temperature is less than 35 degrees, so you are putting a low on the coil. So when the coil is low, we know that it will not be energized, the fan will be keep running, because now you can see, as you saw in the previous case, when there is no current flowing through this, so okay, whenever it is low, it is not energized, so it is on. So we'll be getting a 0 when the temperature is less than 35 degrees centigrade, meaning when this condition is true, so that is when the var value is less than 72 or 74, so that you can clearly verify. When this condition is true, we are actually putting a low on the fan output, so that's why it is not energized. So actually it is de-energizes the coil, and it will be keep running. The fan will be keep running because it is the fan or the bulb is now connected with NC in the common. Suppose if this statement is false. So when does this statement is false? If the temperature is more than 35 degrees centigrade. So then this condition is false. When this condition is false, we are putting a high onto that pin number 3, that is pin number 10 here. So pin number 10, which will be connected to the relay here. So this relay, as you can see now, so this will become high. When this becomes high, so the transistor turns on. this is energized. So when it energizes, this will be get connected to NO. So when it is connected to NO, the motor is not getting the supply. The motor automatically turns off. See here, when the temperature is more than 35 degrees centigrade, then this condition is false. When this condition is false, we are putting a high onto pin number 10. That 10 is interconnected to the uh, coil of the relay. So when that coil is energized, so that fan will be get turned up. So this way we can ensure that if the temperature goes above 35 degrees centigrade, the fan turns off. If the temperature is less than 35 degrees, so fan will be keep running. So we could able to easily demonstrate this experiment if you are writing this code. So make sure that, of course, this is 72 or 70. I think this would have been 72 here. So that is, you can make it 72 and you can keep on observing the value on the serial port, so that we can able to monitor the fan depending on the temperature of the temperature sensor.